So we're going to finish up what we started with yesterday. We have basically just a couple things we want to look at. Word problems. The type you're going to get with rational numbers, generally not exceptionally difficult, and especially people generally find the decimal ones not very bad. So let's take a peek here. We've got, it's not working, there we go, sorry, technical problems. Problem, temperature at the blood reserve decreased by 1.2 degrees Celsius per hour for 3.5 hours. It then decreased by 0.9 degrees Celsius per hour for 1.5 hours. What was the total decrease in temperature? So in this case, we've got it dropping by this much for this amount of time. And then it changes to this and this amount of time. So as soon as we see decreased, what this really means is that this number here and this number here are negatives. So really what we're looking at is we're saying, okay, decrease in temperature, the total. As soon as we see the word total, it means we're going to have to add something. So we're going to have to figure out what the decrease was for these 3.5 hours, and then add it to the decrease in this 1.5 hours. So let's take a look here. So basically we're looking at negative, first one, 1.2. You could add the units if you want, degrees Celsius per hour for 3.5 hours. I'm just going to show with the numbers for now. 3.5 hours. Okay, that's the first bit. Okay. And then we're going to add that to the second bit. And again, this is a negative because it's decreasing. So we can change the question by making one of them increase or something, but we're not going to do that. Now remember, remember that you are supposed to be writing this down. So if you have not started writing this down in your booklet, take the time now, pause it, go do that. Yep, do it now. Do it now. Alright, thanks. Okay, so you're writing this down. Multiplication, so think order of operations, right? Head to mass, brackets, exponents, division, multiplication, addition, subtraction. So in this case, we got to do the multiplication first on both sides here, and then do the addition last. So negative 1.2 multiplied by 3.5, got negative 4.2. So in the first 3.5 hours, it drops by 4.2 degrees Celsius, and then we're going to add that to the second hour and a half. Negative 0.9 multiplied by 1.5, so 1.35. And what you see right here in front of you is probably the best example of why it makes sense to put brackets around the second integer or second negative number, simply because if you have a plus minus, it sort of just looks weird. At this point, we're going to add them. You could, I suppose, do this pencil and paper, but you don't need to. So we're looking here at negative 4.2 plus negative 1.35, and we end up with a grand total of negative 5.55 degrees Celsius. Sometimes you'll be asked to round to one decimal place or something like that, in which case we're looking to say, okay, we're rounding to one decimal place, so this is the one that might go up or down. This one. And so we look at the one right before that. If it's 5 or higher, goes up. If it's 4 or lower, it goes down. This would round to approximately negative negative 5.6 Celsius. Okay. Second part, we're going to be looking to see. Oh, that's kind of fun. Yeah. Oh, that was fun. You need to see that again, you're going to have to rewind the video. Second part here, what's the average rate of decrease in temperature? And so in this case here, we want to find out, to figure out the average, equals total decrease oops. Let's go with, instead of total decrease, we'll go with total change. This is the messiest writing ever. Divided by the total time. And so again, our total change, we're going to use the unrounded number here. So negative 5.55 degrees Celsius. This is just a good habit. Don't round until the very end. Use the unrounded numbers as much as possible. And the total time, so here we have to look back at our actual question. We had 3.5 hours, and then we had 1.5 hours. We have to add those together. 3.5 plus 1.5 would be 5 hours. And our average rate of decrease is going to end up being negative 1.11 degrees Celsius per hour. Or, again, we could round that to negative 1.1. Alright. So your job right now, look at the key ideas here. Remembering, if you multiply or divide two rational numbers, if they're the same sign, negative or positive, your answer, the product, the quotient, is going to be positive. If they've got different signs and you're multiplying or dividing, again, your answer, your product or quotient, is going to be negative. A couple examples here. Order of operations is exactly the same for rational numbers as you've always dealt with. Okay, so we got brackets, that's the B. Exponents, that's the E. You won't be dealing with those for a little bit yet. Division and multiplication, just go left to right with those two together. And addition, subtraction, same thing, moving left to right. Which takes you to your assignment. Textbook, a few questions. Let's get to work. When you're done those, you've got some problems of the week. You can do them in whatever order you want. This is the first one. Sorry, zoom in so you can see it. Okay, this is probably the most simple one. A little bit of the, let's look at some sports and do some problem solving using a little bit of rational numbers and fractions and time. Question 2. Some patterns and following rules. Follow the directions. It's not exceptionally difficult. It's not what you'd normally think of as quote-unquote math, but it's a good problem. And then finally, our tricky one. Same kind of an idea here. Now, just to give you a start on this one. 16 islands of math are represented by the circles shown in the diagram below. The lines between the islands represent bridges. Each bridge connects the two islands attached to it. Two islands are said to be adjacent if they are connected by a bridge. Not every island has water. The number on each island indicates the number of islands adjacent to it that have water. For each island, determine whether it has water or no water. Alright, so the ones that have water, we'll put a W. No water, we're going to put an N. So we start looking at this and say, okay, well, the easiest one is this guy here, 0. nothing that it touches has water. So this is an N, and this is an N. We still don't know if it has water or not. We'll get to that. Then we can look at this guy here. All right. Now this, I should say, this one here too has right now 2 islands that it touches have water. The problem is it's touching 1, 2, 3, 4. Now this one doesn't have water. It's got an N already, but this or this or this could have water. Not very helpful. Let's look at the 4. Ooh, it's touching 6, right? 1, 2, 3, 4, 5, 6. But 4 of them have water. This one has to have water. This one has to have water. This one does, and this one does. All right. I look down at the 2 at the bottom here, and it's got 1, 2 that have water, which means this one doesn't have water. Okay. I look at the 3 here. We've got water there. That's 1, 2, 3, 4. Oh, there's a no water, which means this guy's got water, and this one's got water. Right? And you're going to want to just continue your way through following those set of rules and see if you can find out for each island, does it have water or no? Thanks and good luck. I'm going to ask for all of the problems of the week to get turned in when you're finished. Thank you.